Lesson 71. We're going to start with trinomials with common factors, and that is 71A. So trinomials with common factors. All right, all that means is that we are going to factor something out before we factor our trinomial into a quadratic. So when you have, let's start with 71.1. I'm going to change colors so you can see the problem itself. If you're given a problem to factor x cubed plus 6x squared plus 5x, it's pretty obvious that we have an extra x in here because we start with an x cubed and we are supposed to start with x to the second degree and then in descending order. So we can go ahead and factor out an x to simplify, and that brings us down to x squared plus 6x plus 5. And then we are able to factor this more effectively. So we would then set up our two sets of parentheses in step 1, and then we would factor our first term, and then we would look at the factors of our third term, positive 5, and what would give us a positive 6? Well, positive 5 times positive 1 would give us a positive 6. So that is our factors, positive 5 and positive 1. Pretty easy peasy. Okay, and you could check that with the FOIL method if you would like, but that is the correct factorization. So this will be your answer. You have to include this factor that you factored out in the beginning, kind of your pre-step, and all of your parentheses sets, both of your parentheses sets. So that'd be what I would be looking for when you type it into the system. All right, let's move on to 71.2. So we do 71.2. We are given 4bx cubed minus 4bx squared minus 80bx. All right, so the first thing we look at, is this in ascending order or descending order of degree? Yes, it is. So that's in the proper format in that regard, but it has too many degrees. So we need to take a degree of x out, right? So we're going to take out an x. But it also has an extra variable in each term that we can take out as well. And it also has a whole number that we can factor out. So we could take a 4 out of the first one and we're left with bx, we take 4bx out of the first one, we're left with x squared, right? If we take 4bx out of the second one, we are left with x. And if we take 4bx out of the last one, 80 divided by 4 is a negative 20. Because we took the bx out when we factored out the 4. So now we can factor this like we normally do. 4bx, set up our two parentheses, factor our first term, and now find the factors of the second term that give us the third term that give us the second term. So the factors of negative 20, that could give us a negative 1x, because that's what this is. There's a 1 right there. Would be negative 5 and a positive 4, because when they are combined, we are left with a negative 1. So we drop negative 5 and positive 4, and that's going to be our factorization of this trinomial. Okay, this would be the right answer here. That's what you would type into the system. All right, 71.3. we are given negative x squared plus x plus 20. So what's wrong with this? Why would we do any kind of pre-factoring on this? X, the first term of x squared, is negative. We never want to have a negative first term, because then you have to figure out, okay, well, it affects these terms in the back. You know, which one is negative, which one is positive. You have to play around with that. It becomes more of a headache. So it's easier just to go ahead and factor out the -1 so that your x squared term is positive. So if you factor out a -1, you would then have x squared minus x minus 20. That's going to be easier for us to factor now. And technically, you can drop the -1 and just say negative, and then set up your 2 sets of parentheses, and then we'll begin factoring, because we know that the 1 goes in between here. That is a default when you have a negative. So you can type it in as -1, or you can take it out. Either answer will be correct. So we factor our first term. Now we look at the factors of the second term, which is -20, to leave us with a -1. Isn't that what we did up here? It should be the same factors, right? So -20 be -5 times +4. That leaves us with a -1, same factors. So it's going to be -5 plus 4. All right, and this would be our answer. And if you want to put the 1 in there, you can, but you can also just leave it as a negative. That's okay. All right, 71.4. What if we're given -3x cubed minus 6x squared plus 72x? I see a couple things we can take out. Why don't you pause the video and see if you can factor this out effectively, and when you're done, press play and come back and see if you have the same answer that I do. All right, I'm going to assume that you paused and worked out the problem yourself. I'm going to switch colors. So the first thing I would factor out, I see an x in each term, and each term is divisible by -3. So I would take out the -3x first. And then I would simplify those terms by -3x. So that will leave me with an x squared, and then a +2x, and then -24. And if you go back and multiply -3x times each of these, you should come back to the beginning. And that's correct. So now we're going to factor our trinomial into a quadratic. So we factor the first term, and then we look at the factors of the second term that would give us, or the third term that would give us the second term. So the factors of -24, that could give us a +2, is going to be +6 and a -4, because when combined, they leave us with a +2. So that is our factors. We're going to drop into +6 and a -4. And that is going to be the answer to 71.4. So I hope you're seeing the pattern. You will have some practice problems to do that you can do over and over again until you figure out this pattern here. Pull out what is common to each term. Then you should have a second-degree trinomial in descending order. Set up your 2 sets of parentheses, factor the first term, find the factors of the third term that give you the second term, and drop them in. And that should be all you need to do. All right, now we're moving on to the second part of lesson 71, which is subscripted variables. All right, subscripted variables. It's just a different type of variable. It is not difficult at all. Think about when we're first tempted to write a variable, we want to make it describe kind of what we're doing. That's all a subscripted variable is. It's a better descriptive variable. So for instance, if I were to use, if I had a number of dimes as in a problem, as a variable, I might write the number of dimes. And that's a subscripted variable because you have a second subscripted variable or description, I guess is a better word. You have a subscripted letter down here that's giving further description of this first letter that you're using as a variable. So I could say number of dimes, I could say number of nickels, I could say number of quarters, I could say number of pennies. It's just a little bit more of a description. So you don't have to say over here, X is equal to the number of pennies. And then this would be, X. No, you would just put number of pennies here. You put NP. So you wouldn't have to have a key or a legend. You're just using the variable as your descriptive mechanism. So it's actually a little bit easier, but it looks more complicated because you have two letters instead of one. That's all a subscripted variable is. It's a more descriptive variable in a problem. So let's do 71.5, and I'll show you what I mean. We're going to use elimination to solve this problem. And we remember what elimination is. It's where we set up our terms so that one of them will cancel out. So we are given 5 times the number of nickels plus 10 times the number of dimes equals 125. Now, why do we say 5 times the number of nickels? Because a nickel is worth 5 cents. So 5 times however many nickels we have is going to give us the value of those nickels, right? Same thing for dimes. We said 10 times the number of dimes, because 10 times 1, if we have 1 dime, that's 10 cents. So that makes sense. It's just a more descriptive way to write your variable so you can kind of keep track of what you're doing. You don't have to remember that 5 is nickels and 10 is and y is, X is nickels and y is dimes. It's already in your variable which is which. Okay, so the second equation we're given is the number of nickels plus the number of dimes equals 16. So we're going to use elimination to solve this. So we're going to leave this problem, this equation as it is, and we're going to multiply this problem or this equation. So this one becomes 5 times the number of nickels plus 10 times the number of dimes equals 125. That remains the same. But we're going to multiply this times -5 because we want to eliminate. And I'm choosing to eliminate the number of nickels because it's the smaller of the two. It'll just be easier to calculate. So we're going to multiply times -5. And that's going to give us -5 times the number of nickels and -5 times the number of dimes. And that's going to equal -80. Let me double check. Yes. -80. And now we're going to use elimination. Those would cancel. This would become 5 times the number of dimes equals 45. So when we divide both sides by 5, we get that the number of dimes is equal to 9. The variables are just more descriptive. They are exactly the same as using an X or a Y. They just look a little different. They look complicated, but they're the same process. You don't have to change the way you're doing the problem. It's like if you had a star instead of an X or a fish instead of a Y. They just look different, but they are treated exactly the same way. So now that we know that the number of dimes is 9, we sub that in. So the number of nickels plus 9 equals 16. We subtract 9 from both sides. We know that the number of nickels is 7. So those are our answers. The number of nickels is 7 and the number of dimes is 9. And what this does is this allows you to solve using substitution or elimination for more than just x and y. Okay, it allows you to expand and possibly even do problems with 3 terms or 4 terms by giving you a wider variety to pull from. So let's move on and do 71.6. And with 71.6, we are going to use substitution instead of elimination to solve. So we are given 5 times the number of nickels plus 25, and we're going to use quarters this time. So 25 times the number of quarters equals 290. And we're told that the number of quarters equals the number of nickels plus 2, right? So we can sub in for the number of quarters this binomial. So let's do that. 5 times the number of nickels plus 25 times, and we're going to sub in for the number of quarters this value here. Number of nickels plus 2 equals 290. So 5n plus, and let's do our distribution, so it's 25 times the number of nickels plus 25 times 2 is 50. We can subtract 50 from both sides, and then we'll combine these two to give us 30 times the number of nickels equals 240. We're going to divide both sides by 30. And we're going to reduce this fraction before we divide because we can. We're going to reduce it by 10. That gives us n. Number of nickels is 8. Okay? So you see the variable does not, just because it looks different, it's still just a variable. That's all it is. And the subscript letter at the bottom goes with whatever the capital is to the left. All right, so you have a left and a right, top and a bottom. They go together as pairs. It's just a further descriptive type of variable. So now we can sub in 8 for the number of nickels and figure out how many quarters we have. So the number of quarters is equal to 8 plus 2 because the number of nickels is 8. So the number of quarters we have is 10. And those are our answers. Voila.